So try to answer this. So from the question, when you read the question, you will be able to draw the circuit, how the circuit is. Uh, it said that a connection is made by resistance A in series with a parallel combination of B and C. So there is a resistor A in series with a parallel combination of B and C. Okay, A, B, and C. There are three resistors, and A is in series with parallel combination of B and C. Three resistors of value. You have three resistors: 10 ohms, 5 ohms, and 2 ohms are provided. Consider all the permutations. So you have to keep these three resistances: 10, 5, and 2. 10, 5, and 2. 10, 5, and 2 in the places of A, B, and C. You can keep 10 anywhere, 5 anywhere, and 2 anywhere, but you have to use all the three resistances, and you have to find the maximum overall resistance and minimum overall resistance, and the ratio of maximum to minimum. The ratio of maximum to minimum value of resistances, you have to find that. That is the question given in GATE 2017. So this is a 2 marks question, and it's a very important question. So you have to understand some concepts here. See, when two resistors are in parallel, or what you call in parallel, when two resistors are in parallel, the equivalent resistance, the overall equivalent resistance will be will be less than the minimum of both the resistances. For example, I'm having a 10 ohm resistor and I'm having a 100 ohm resistor, so the R equivalent will be less than 10 ohms. Okay, if this is 1000, still 10,000, any amount of zeros, the overall resistance will still be less than this value only. Okay, you have to remember this. If there are two resistors and connected in parallel, the equivalent resistance will be less than the minimum of the minimum of both the resistances. This is valid in case of parallel networks. Okay, so I hope you're taking down in your notes. Okay, this is one of the important concepts. Okay. So coming to the question again. So now you have three resistances. The combination is given. The combination is like this: A, B, and C. Now you have to find the equivalent resistance, keeping 10, 5, and 2. So tell me, if I want for maximum resistance between these two terminals, maximum resistance. So if I have the minimum resistance of 2 ohms here, or 2 ohms here, and so sorry, if I use 2 ohms here, I have 10 and 5. 10 and 5, which should be A and which should be B? If this is 10 ohms and this is 5 ohms, the parallel combination will be less than 2 ohms here. Okay, less than 2 ohms, and this will be in series. So if I use 10 ohms, this will be minimum. The value you'll get is less. So what should be the combination for maximum? This is 2, this should be 5, and this should be 10. Maximum resistance 10 plus 5 parallel with 2. Everyone clear with this? How I got the maximum resistance? Shall I repeat it? You can unmute and ask me if you have any doubt. Okay. So for minimum resistances, from minimum value of resistance. So meanwhile, file the value 10 by 7. 10 plus 10 by 7, 70, 80 by 7. Okay, maximum resistance is 80 by 7. Okay, now I want to find the minimum resistance. Minimum resistance. From minimum resistance, I want 2 here. I can have 10 and 5 combination here. or I can have 5 here and a combination of 10 and 2 here. Okay, either way, this combination or this combination, we have to check which one is the lowest. If this is combination, this will be less than 2. If this combination is used, less than 5. So I have to find both ways. So what I'll do, I'll find this one using 10 5 parallel with 2 parallel with, okay, or I'll take minimum of 2 parallel with 10, sorry, 2 series with 10 parallel, 2 plus 10 parallel with 5, or 5 plus 10 parallel with 2. Okay, so minimum of these two. So 10 parallel with 5 is 10 by 3. 10 by 3 plus 2, so 16 by 3, comma 5. 10 parallel with 2, 20 by 12. 20 by 12 plus 5, or like 20 by 12 is sorry, 20 by 2. 20 by 12 is 5 by 3. 5 by 3 plus 5, 18 by 3. So this is the minimum. 2 plus 10 parallel with 5. So minimum is 16 by 3. So ratio will be max to minimum. Ratio will be 8 by 70 divided by 16 by 3. Tell me the answer. Answer is 15 by 7. Achha. Answer is actually 2.14. Just check it if. 7. Yeah. Yeah, correct. 15 by 7. Okay. I hope everyone are following this. Following me. Okay. Shall I move on to the next question, or shall I explain it again? This particular question, you have to apply the logic is if two resistances are in parallel, it should be the equivalent resistance will be less than the minimum value of both the resistances. Okay. Moving on. Yeah. Find the effective resistance between A and B. The gate question. Try to solve this. Find the effective resistance between A and B. The last question is clear to everyone, right? This is an online class. I need responses from everyone. Presently, I see only one person typing, or one person is answering. If the last question is clear, try to find the answer for this question. Effective resistance between the terminals A and B. Find the resistance between terminals A and B. Any answers? You have options A, B, C, D. Answer C. Right. So how did you do it? So if you are thorough with the classes in the previous classes, you can directly answer the question. If you're thorough with, if you are following me in the last previous classes, you can directly answer the question. Yeah, you have a delta here and a star here. So you can do that star to delta stuff from the center, or if you see, except this resistance, if I see from the terminals here, if I see from the terminals of A and B, except this resistance, this whole thing is a Wheatstone bridge. If you can see this, this is a Wheatstone bridge. Okay. Okay, are you able to find it? The Wheatstone bridge between these two terminals? Let me draw it for you. There is a resistance parallel with the Wheatstone bridge. This is AB. This point I'll call it as O. Sorry, yeah, OB and C. So A to O, there is a resistance, and O to B there is a resistance. These are A and B terminals, right? So O to B, B to C there is a resistance, and A to C there is a resistance, and O to C there is a resistance. If you can able to find identify this, okay. So this is how a Wheatstone bridge is. So if all the resistance of a Wheatstone bridge is equal, what is the equivalent resistance? If all the resistances of the Wheatstone bridge are equal, what is the equivalent resistance?
R by 2.
No,
R
if
by 2.
all the resistances of a Wheatstone bridge are equal, then the equivalent resistance is R. R is in
Yes.
parallel with another R, so you'll get the equivalent as R by 2. Okay, this at these terminals the equivalent resistance is R. So R is in parallel with R. The equivalent resistance is R by 2. Is this clear? The only thing is you can do that. You can see when a balanced Wheatstone bridge is there, you can easily simplify it. Otherwise, you can do that star delta or delta to star. You can do all those stuff, but it's easier if you can identify the circuit properly. Okay. Okay. Shall I move to the next question? Okay. Yeah. If I equal to 2 amps, find the value of voltage source V. If I is equal to V, I equal to 2 amperes, find the value of voltage source V. So this is I given. These are 0.5 ohms, 1 ohm, 1 ohm, 1 ohm. Find the value of voltage source V. Any answers? How do you want to do this? I think you might just had your lunch. All people are sleepy. 2 volts. Right. Okay. So how did you do this? So do you see any star delta or any other combinations? Yeah. See, if you see these two are in parallel, 1 ohm and 1 ohm are in parallel. So when 1 ohm and 1 ohm are in parallel, what is the equivalent resistance? 1 ohm parallel with 1 ohm. Equivalent resistance is? So 1 ohm parallel with 1 ohm, what will you get? So this is 1 ohm. So these two are in parallel. You have this is 0.5 and you'll get 0.5. So the total resistance here will be 1 ohm. So 5.5 and 0.5 ohm series will give you 1 ohm, and the current given here is 2 amperes. So you'll get something like this. This is V, 1 ohm, 1 ohm, and the current here is 2 amperes. So these three are in parallel. If I find the voltage across one of these, the voltage value will be the same. So this is 2 amps and 1 ohm. So the voltage across this resistor is 2 into 1, 2 volts. Right? These are all previous year gate questions. Previous year gate questions, you'll obviously get what you call direct numericals. Okay, I hope this is clear with everyone. So in the last class, we were dealing with what you call Kirchhoff's voltage law and Kirchhoff's current law, and then nodal and mesh analysis, right? We were talking about super mesh analysis. Okay, I think we did a problem on super mesh analysis, right? Okay, did we do this problem in the last class? Okay, this problem is done, right? So we'll do the next one. So find the mesh currents I1 and I2. Find the mesh currents I1 and I2. We will do using mesh analysis. Find the mesh currents I1 and I2 using mesh analysis. Okay. The mesh analysis, again, you have two meshes. So let me name it for the first. A, B, C, D, E, and F. So mesh 1, what is mesh 1? A, B, E, F, and A. Starting with A, I'm going through A, B, E, F, and again back to A. This is mesh 1. So what I should do? I should write all the voltages in terms of currents, mesh currents. So the voltage drop across this 2 ohm resistor will be 2 into I1. Okay, and this is 2 into I1. I want to write all the voltage drops. Okay, 2 into I1 plus 12 into what is the current in this branch? If this is I1 in this direction, and I2 in this direction, this will be I1 minus I2. Okay, plus 4 into I1 minus 36 is equal to 0. Minus 36. The first one you encounter in the voltage source. The first terminal you encounter in the voltage source, you have to do this. So this is 2 plus 4 is 6 plus 12, 18 I1 minus 12 I2 is equal to 36. Okay. This is my equation 1. So again, mesh 2. Mesh 2 is B, C, D, E, and B. B, C, D, E, and back to B. Starting from B, tell me what is the mesh analysis equation? 9I2 plus 24 plus 3I2 plus 12 into, see again here the voltage drops are this way. So this will be 12 into I2 minus I1. I2 minus I1 is equal to 0. Okay, so from this minus 12I2, sorry 12I1, so you have 9 plus 3 12 plus 12 24 plus 24I2 is equal to minus 24. So this is my equation 2. Solve equation 1 and 2 and tell me the values of I1 and I2. Solve equation 1 and 2 and tell me the values of I1 and I2. Okay, so what are the values? Okay, 4 and 3. Correct. 4 and 3. 4 amps and 3 amps. Okay, everyone clear with this? I'm moving to the next one. So find the mesh currents I1, I2 and I3 in this question. Find the mesh currents I1, I2 and I3. So do you see anything in this question? Mesh currents I1, I2 and I3. So we have a current source in series with a resistance between two meshes. A current source in series with a resistance between two meshes. So there is something called a super mesh. When you call a mesh as a super mesh, when there is a current source between two meshes, there may be a series resistance with the current source, doesn't matter. Similarly, what is a super node? What is a super node? What is a super node? Super node when there is a voltage source between two nodes, two non-reference nodes, when there is a voltage source, and if there are any parallel resistances with that source, you can neglect them. Similarly, if there is a current source in series with any resistance, you can neglect them and you have a super mesh here. Okay. So again, I'll write something like this. A, B, C, D, E, F, G and H. Okay, tell me what is the mesh one here? Anyone? Mesh equation one? Mesh one equation. So as there is a as there is a current source and a resistance between mesh one and mesh two, what will you write? You will write a mesh equation for one and two. Only one equation for one and two. And two. So it will be A, B, E, D, F, H and A. F, G, H and A. Okay. F, G, H and A. You understood this? So this is how you travel. So you will travel this way. Okay, you will neglect the current source in series with the resistance. So tell me the equation here. If I start from A, B, there is nothing. Then B to E. What is the value B to E? 2 into I1 minus I3. I1 minus I3. Then 4 into again I2 minus I3. I2 minus I3. Then 8 into I2. Then minus 6 is equal to 0. So I can write it as 2I1 plus 8 plus 4, 12I2 minus 2I3 minus 4I3 minus 6I3 is equal to 6. This is my equation 1. Okay, so I'll write directly for mesh 3. Mesh 1 and 2 is done. So I'll write mesh 3. Mesh 3 will be, tell me, B, C, D, E and B. B, C, D, E and back to B. So tell me the equation here. 2I3 plus 4I3 minus I2. I3 minus I2 plus 2 into plus 2 into I3 minus I1 is equal to, okay, 2 into I3 minus I1 is equal to 0. So again here minus 2I1. So I2 will be minus 4I2. I3 will be 8I3 is equal to 0. So this is my equation 2. So how will I get my third equation? I have three variables, I1, I2 and I3. So I have two equations in I1, I2, I3. So how will I get the third equation? How will I get the third equation? Anyone? How will I get the third equation? Using a supermesh equation. Supermesh equation is this one. The current is downward direction, so it is I1 minus I2. So I1 minus I2 is equal to 3 amperes. Okay. So I1 minus I2 is equal to 3 amperes. So I have 3 equations and 3 unknowns. Find the values I1, I2 and I3. Tell me the values. I1, I2 and I3. Tell me the values for I1, I2 and I3. 3 equations and 3 unknowns. Yes, I1 minus I2 is equal to 3 is the supermesh equation. So I think you can use your calculators and find the values of I1, I2 and I3. So any answers? I hope you are able to follow me. Okay, I'm giving you the answers. I1 is 3.474, I2 is 0.47, and I3 is 1.10. Okay, all these are amperes. Okay, I hope everyone got this. Okay, so let me. Okay, this is for the what you call supermesh equation. In the previous question, if you see this, I have a shortcut to tell you. So you can directly write something like this. So in the previous question also, if you want, you can directly write the mesh equations directly like this. So mesh 1, if you see this, so all the resistances, so add all them in the first mesh. 2 plus 12 plus 4 is 12 plus 4 is 16 plus 2, 18. So the current in that mesh, 18 I1. Okay, and the common resistance, so you have to have the opposite sign in the common resistance. 12I2 is equal to the source voltage 36. This is the equation, first equation. Okay, you have to add all the resistances in the circuit, in that mesh. Okay, so mesh 2 also similarly. Mesh 2, again add all the resistances. 9 plus 3, 12 plus 12, 24. So this will be 24I2 and minus 12I1. Okay, is equal to 24 volts. So this is in this direction, opposite direction. So this will be minus 24 volts. So this is minus 12I1 plus 24I2 is equal to 24 is the mesh equations. You can directly write down the mesh equations in this way. Okay. So similarly for this question also, if you can see the third, this one, third mesh, 2 plus 4 plus 2 is 8. So directly 8I3. 8I3. The common one between first and second is 2 minus 2I1, and this is minus 4I2 is equal to 0. So you can do it that way. Okay, so if you observe this, the value of this resistance, 1 ohm resistance, is not used anywhere. So the value of this resistance is irrelevant, because whatever the current from this source 3 amps will flow through this resistance, and you don't need to find the current through this resistance separately. So this current source forces 3 amps to this resistance. Okay, so only when you consider the power consumption, then only you'll consider this resistance. Otherwise, you don't have to consider for finding the currents and voltages across any element. Okay, so any doubts? Am I clear?
Sir, can you go to the previous question again?
Yeah, this one,
In
right?
this, yes, sir. In this,
Hmm.
why is 36 positive but 24 negative?
So if you see this, if you go through the circle, or what you call loop, so the first thing you encounter is minus here. If you go through
Yes.
this mesh, the first thing you encounter is plus here.
Okay, okay.
Yeah,
All right,
that's
sir.
the main
Got it.
thing.
Got it.
Okay. Okay, we are done with this question, right? Yeah. Next one. So find this. This is this. What is this? Again, what is this one? Everyone, what is this one? This question. This is a dependent source. What kind of dependent source is this? It is a VCCS. It is a voltage dependent current source, or voltage controlled current source. Okay, the value of this current source is dependent on the voltage across this 2 ohms resistor. So this is what you call it as a VCCS. This is a VCCS, voltage controlled current source. Okay. So try to do this. I'll solve this one for you, and I want you to do the other problems. Okay. So this is given in the given circuit. The parameter K is positive. Okay, the parameter K is positive, and the power dissipated in the 2 ohm resistor is 12.5 watts. The value of K is you have to find the value of K. Okay, power dissipated in the resistor is given. Okay, so I can find the current through that resistor or the voltage across that resistor. Okay. Okay, for that, let me. Okay, power through the 2 ohm resistor is 12.5 watt. So this is nothing but V naught square by R is 12.5, and V naught is under root 12.5 R. So find the value of V naught. R is given as 2 ohms into 2. 25 root is 5. This is 5 volts. Okay, now if I want to find the value of K. For that I need to know the current here. Okay, for that I need to know the current here. So what I'll do is I'll apply something called as a nodal analysis at this. You consider this node voltage as V. Tell me the node equation at the node V. Or what else you can do is you can use a mesh analysis. You can use mesh analysis or nodal analysis, because see, I have two meshes and there is a current source between the mesh. So this is a super node, and I can what you call I can have the one equation only. Or what else you can do is, so can someone tell me the current here? So the voltage across this is 5 volts and the resistance is 2 ohms. Current is, I'll call it as I. I is 5 by 2, 2.5 amperes. Okay, 2.5 amperes. Okay, so this is 2.5 amperes. So tell me the node equation at this. All the what you call outgoing currents are positive. All the outgoing currents are positive. So this is an incoming current minus 2.5, and this is also an incoming current minus K into V naught, and this is an outgoing current, so plus 5 is equal to 0. I have the value of V naught as 5 minus 2.5 minus K into 5 or 5K plus 5 is equal to 0. So okay, or let me write it this way. Or the current here I'll consider it as Ix. So plus Ix is equal to this. So what is the value of Ix? It's minus 2.5. Or kV naught is equal to minus Ix. So this is 2.5. And V naught is 5. K is 2.5 by 5. Did you get it? V naught is 5. K V naught is equal to 2.5. And V naught is equal to 5. So K is equal to 2.5 by 5 is 0.5. K is 0.5. Is it clear? 2.5. Okay. Okay. Shall I move to the next question? Okay. Moving on. So find the values V1 and V2. This is also a previous year GATE question. Find the values of V1 and V2. So can someone tell me the answers? Try to solve this using all the methods you have so far. Okay, I'll give you 30. Any answers so far? Find the values of V1 and V2. It's a GATE question. Okay. Okay. Shall I do it? Or shall I wait? So again, what kind of source is this? What kind of source is this? V1 is 2.5. Okay. So what kind of source is this? This is a current source, and the value depends upon the current. So this is a current dependent current source. This is a CCCS, current dependent current source, or current controlled current source. Okay. So what all we can do? We can use mesh analysis, nodal analysis, right? So I'm having only one node, so it's better to take nodal analysis. So what can I name this node? This is the voltage here as V1, because the voltage across this will appear across this as well as this. So this voltage is V1. So tell me the equation at this node V1. So the current, all the leaving currents, this is minus 5 amperes. So I don't need to write the equation in terms of voltage here. Minus 5 plus V1 by 4 plus V1 by 4. So leaving current plus 2I is equal to 0. Is this clear? So again, what is I? I is nothing but V1 by 4. So replacing I here, minus 5 plus 2V1 by 4 plus 2 into V1 by 4 is equal to 0. 2V1 by 4, 2V1 by 4 is V1 is equal to 5. V1 is equal to 5 and V2. So how do you find V2? V2 is the voltage across this current source. So let me draw it again. So this is a 5 amp source and a resistor of 4 ohms, and here you have a voltage of V1 equal to 5 volts. So I want this voltage V2. So if you can write down the equation here, minus V2 plus 4 times the current here is 5 plus V1 is 5 is equal to 0. So V2 is equal to 5 was 20 plus 5, 25. These are the answers. Am I clear or shall I repeat it? 30 and 10. No. V1 2.5. No. V1 is 5, V2 is 25. Is it clear or shall I explain? I'm getting different answers, everyone. 2.5, 30, 10. Can you explain V2 again? Okay, V2. Yeah, V2, if I consider this portion of the circuit, this is my voltage. This is my voltage V1. Already found V1 as 5 volts. So the voltage across here is 5 volts. So I'm drawing this separately. So this is my V1 and this is V2 across the current source. V2 is the voltage across the current source, and this is a 4 ohm resistor where 5 amps is flowing. So this current source will flow, what people will force 5 amps to flow from this. So what happens if I draw the mesh equation here? The first thing I encounter is minus V2. Then plus 4 into current here is 5. 4 into 5 plus the voltage here is 5 volts. Plus 5 is equal to 0. So 4 5 is 20 plus 5 25. V2 is equal to 25. Is it clear? Okay, repeat the whole thing, or shall I repeat it again? Sakura Beshra. Whole thing, sir. Okay. So the whole thing is node V1. If you see the node V1, tell me the node equation at V1. The leaving current is minus 5 amperes plus V1 by 4 plus V1 by 4 plus 2I. This is the current value. This is a current source. The current value is 2I is equal to 0. And again, what is I? I is nothing but V1 by 4. I is nothing but V1 by 4. This is I, not I1. Okay, I is nothing but V1 by 4. So substituting the value of I in this, what will I get? Minus 5. Okay, minus 5 is same. So V1 by 4 plus V1 by 4 is 2 V1 by 4 plus 2 into I is V1 by 4. So 2 into, okay, 2 into V1 by 4. So again, I have 2 V1 by 4 plus 2 V1 by 4 is 4 V1 by 4. That is V1. V1 is equal to 5. Okay, when you take V1 as 5, so applying the mesh equation here, it will be minus V2 plus 4 into 5. 4 into the current through this is 5 amperes. 4 into 5 plus 5 is V1 plus 5 is V1 is equal to 0. So hence from this V2 is equal to 25. Is it clear? Okay. Moving on. So everyone find this. This is again a gate question. In the circuit shown, determine the ratio of V2 by V1. I'm giving you 30 to 40 seconds time. I want you to answer this. Use your mesh analysis or nodal analysis, whatever you find is appropriate, and try to find the ratio of V2 by V1. Any answers? Shall I wait or shall I do it? Any answers? Response? Okay, I'm doing it. I want the ratio of V2 by V1. I want the ratio of V2 by V1. So tell me, what is the node equation, node voltage here? The same value, right? Everyone look at the screens. Everyone look at your screens. So whatever the voltage across this is V2, that will appear across this resistance also. So this node voltage is again V2. Okay, so tell me the node equation at the node V2. This is 2. So tell me the node equation at V2. Anyone? You can unmute and tell. Unmute and tell. Tell me the node equation at node V2. Everyone to your screens. Shall I write or is someone going to tell me? So okay, this is V2 minus V1 by R1. Okay, V2, the leaving current is V2 minus this voltage is V1. V2 minus V1 by R1 plus the leaving current here is V2 by R1. Here the leaving current here is minus alpha I is equal to 0. Is this clear so far? Everyone able to write the equation, right? Shall I repeat the equation again? Node equation. If you can write the node equation, it's direct. The answer is direct. If you can able to write the equation direct, the answer is direct. What kind of source is this again, everyone? What kind of source is this? What kind of dependent source is this? Or control source or dependent source? This is a, everyone, what kind of dependent source? Am I audible to everyone, right? No, it's not a VCCS. It's an CCCS, current controlled current source. Current controlled current source. The value of this is alpha is a constant, so it depends upon the value of current I. I is the current flowing here. This is a current source. Its value depends upon the current flowing and through that resistance R1. So this is a current dependent current source. Okay, is that clear? Current dependent current source. Yeah. Okay. When you have clear that, is this clear? The node equation. Node equation is clear, right? Okay. Node equation is clear. So tell me what is I from this? What can I write? I is equal to V1 minus V2 by R1. V1 minus V2 by R1, right? I'm replacing here I. I'm replacing I here, so this will be V2 minus V1 by R1 plus V2 by R1 minus alpha into V1 minus V2 by R1 is equal to 0. So what happens now? So this will be V1. Let me write in terms of V1. I'll take V1 common. So what happens? Minus 1 by R1 minus alpha by R1. So this is minus 1 minus alpha by R1, or I'll take minus common. So minus V1 into 1 plus alpha by R1, then V2 plus V2 into, so 1 by R1, 1 by R1, 2 by R1. Okay, 2, sorry, this, yeah, 2 by R1, 2 plus alpha by R1 is equal to 0. So now I got something like this, V1 into alpha by R1 equal to V2 into 2 plus alpha by R1. So I want V2 by V1. I'll get it as 1 plus alpha by 2 plus alpha. 1 plus alpha by 2 plus alpha. Option B. Yes. So only thing is you need to be properly writing the equation at node, proper node equation. Okay, you can use mesh analysis, you can use other techniques also, but when there are dependent sources, one thing even in this previous problem you have to remember is try not reducing the circuit. If I'm having here 4 ohms and 4 ohms resistance, if I make this as 2 ohms resistance, how will I find the equation for I is the current resistance, not the equivalent of these two. Okay, when you see a dependent source, try not to reduce the circuit at least that point where the dependent current is flowing, dependent current or dependent voltage is there. Okay, dependent parameters are there. Don't reduce those networks. Okay. Okay, shall I move on to the next one? Is it clear? Okay. Moving on. So again, a gate question. Find the value of R. This is the circuit given. Find the value of R. Find the value of R. So you have some voltages and currents. You can use either mesh analysis, nodal analysis. You can do either mesh or nodal. Find the value of R. So again, I'll give you 30 seconds time. I want you to try to answer it. If you want more time, you can ask me. If you are doing or you are about to get the answer, you can ask me. I can wait. So one of the concerns in the feedback is that I'm not waiting for you to solve it. I want you to solve it actually. Okay, no answers, right? I'll solving it. So you can use mesh analysis or nodal analysis. See, if I use mesh analysis, I have nodal analysis, I have three nodes, V1, V2, and V3. Okay, so I note these what you call out of three, I know two values. Value of V1 is 100 volts, V3 is 40 volts directly. Okay, this is my reference node if I call this. So I have V1 and V2. Okay, I can use nodal analysis. Otherwise, if I use mesh analysis, I have three meshes, I1, I2, and I3. So I know the current I1 as well as I2. I1 is 10, I2 is -5. So I can use mesh analysis or nodal analysis, doesn't matter because I have two of the three variables. So let me use nodal analysis here. So tell me at the node equation at 1, V1. So node equation at 1 is V1 is 100 volts. Okay, you already have V1 as 100 volts. So node equation will be here. So all the leaving currents at node V1, tell me all the leaving currents. So this is -10 plus V1 minus V3 by R plus V1 minus V2 by 14 is equal to 0. I already have V1 and V3 values mine. Why is this creating problem? It's getting zoomed in. I think there is a problem. Okay, let me log in again. Yeah, I think there is still a problem. Yeah, now can you see everyone? Everyone, now can you see? I think now this is clear. Yeah. Okay. Okay. So you have the values of V1 and V3 here. V1 is equal to 100 volts and V3 is equal to 40 volts. Okay. So substituting the values here, minus 10 plus 100 by R, 100 minus 40 by R plus 100 minus V2 by 14 is equal to 0. Okay, you can simplify this. You'll get an equation in V2 and R. Okay, and at node 2, node V2. So tell me the node V2 equation. V2 minus V1 by 14 plus V2 by 2 plus V2 minus V3 by 40, sorry, plus by 1 is equal to 0. So I have V1 and V3 values. From this I can find the value of V2. So V2 by 14 plus V2 by 2 plus V2 minus V1 is 100 minus 100 minus 40 is minus 140. So from this find the value of V2. Find the value of V2 here. I thought in the meantime you might have done the problem. It's 89.09. 89.09 volts. Okay, so substituting the value of V2 here, you'll get the value of R. Substituting the value of V2 here, you'll get the value of R. Okay, I want you to do this. So simple numerical. Okay, you understood the concept, right? Everyone? You understood the concept? So you can use mesh analysis or nodal analysis. Only thing is you have to find the voltage here. Otherwise, you have to find the current in this circuit. You will get the value of R. Okay, if you use mesh analysis, you have to find the current in the third I1, I2, I3. Out of two currents, out of three, you have two currents. Out of three voltages, you have two voltages. Okay, so this is how you do this. Okay, shall I move to the next question? Am I audible to everyone? Shall I move? Yeah. Okay, moving on. Again, this is a gate question. Find the current I flowing in the circuit shown below in amperes, rounded off to 1 decimal place is dash. Find the current I. Find the current I in the circuit, rounded off to 1 decimal place. It's a gate question, previous year gate question. I want you to do this. What kind of source is this? What kind of source is this? What kind of dependent or controlled source is this? It's a CCVS. Yeah, current controlled voltage source. This is a voltage source whose value is dependent on the current flowing through this current resistor, 2 ohms resistor. So this is a current controlled voltage source. This is a CCVS, current controlled voltage source. Okay, now try to do this. Try to solve this. Any answers? Use mesh analysis or nodal analysis. You can use any of them. Use mesh analysis or nodal analysis, whichever you feel comfortable. See, how many equations will you get if you use nodal analysis? How many unknowns? I hope everyone are trying to solve the problem. Okay, you can use mesh analysis or nodal analysis. Which one you want me to do? If you, I want to try the other one. If you are doing with mesh analysis, I want to do with nodal. If you are doing with nodal, I want to try with mesh analysis. So tell me which should I do? Which method? Mesh or nodal? Mesh analysis. Okay. Okay, I hope everyone is listening to me. I'm getting only few responses. Okay, so if I want to do mesh analysis, so I'll consider this as I, already given I. So this current as I1, I and I1, or I1 and I2, I can consider both. So I can use both mesh analysis and nodal analysis, not a problem, because this is actually a current. There is a current source between two meshes. So what is it? It's a super mesh. Super mesh, you'll have only one equation. So tell me the super mesh equation starting from this point. So this will be 2I. Sorry, mesh equation. You can combine both the meshes. You can combine both the meshes. So tell me 2I plus 3I1 plus 5I plus 5I minus 20 is equal to 0. Minus 20 is equal to 0. Minus 20 is equal to 0. So everyone clear with this? This is 7 plus 3I1 is equal to 20. So this is equation 1. So tell me the super mesh equation. Super mesh equation. Anyone? Super mesh equation. So this is nothing but current is flowing. I can take the leaving current. So what I'll get? So I1 is equal to 2 plus I, or I1 minus I is equal to 2. I1 minus I is equal to 2. Everyone clear with this? So if I see at this node, what are all the leaving currents? Take minus I. So leaving current is minus I. And minus 2 plus I1 is equal to 0, or 2 is equal to I1 minus I. Okay. So I1 minus I is 2. So I can write I1 in terms of I. I1 is equal to 2 plus I. Substitute this value here. What will I get? 7I plus 3 into 2, 6 plus 3I is equal to 20. So 10I is equal to 14. I is equal to 1.4 amps. I is equal to 1.4 amps. So did anyone got the answer? You can do the same in nodal analysis also. If you want, I can try that. Yeah, I can do that. Somebody asked me to do in mesh analysis. That's why I did it in mesh analysis. Shall I repeat? Is it clear or? Please repeat in nodal analysis. Okay. Okay. So this is clear now. In mesh analysis, you got the answer as 1.4 amperes. Okay, I'm doing in nodal also. So I'll take this node voltage as V1 or V. Okay. So tell me the node equation at V. I'm audible now, right? Okay. So V minus 20 by 2. So minus 2 plus V minus 5I by 3 is equal to 0. This is the node equation. Everyone clear with the node equation? So once you can write the node equation, you can solve the problem. This is the main thing. Node equation or mesh equation, nodal analysis or mesh analysis. The main important thing is you should be able to write down the mesh equation properly. Okay, mesh equation properly. So this is the node equation. So V by 2 plus V by 3 is equals to 5V by 6 minus 20 by 2 is 10 minus 10 minus 2 minus 12 plus minus 5 by 3 I is equal to 0. So what is I here? I is nothing but 20 minus V by 2. Everyone clear with I? You should be able to write the in the equation of I. I is nothing but this current. So this voltage is 20 minus V by 2 is I. So this is 5V by 6 minus 12 minus 5 by 3 into 20 minus V by 2. So this is 5V by 6 plus 5V by 6. This is 10V by 6 or 5 by 3V. Okay. Is equal to minus 12 plus 5 into 20 100 by 3 plus 100 by 3. So this will be 5V is equal to 3 12 36 136. V equal to 136 by 5. V is 136 by 5. I need to find the value of I. I is equal to 20 by 2 is 10. 10 minus V is 136 by 5 into 2 10. So this is 10 minus 13.6. Sorry, did I do any mistake? This is 336, 136 by 3. 3 and 3 gets cancelled. Okay, so 136 by 5 is 36 by 5. 27.2. No, I did some mistake. Let me do it again. So to here it is clear. 5V by 6 minus 12 minus 5 by 3 into 20 minus V by 2. V minus 20 by 2 minus 2 minus 5 minus 9. Okay. So 5V by 6 minus 12 minus 100 by 6. Okay, 100 by 6. I take 100 by 3 here. Okay, minus plus 5V by 6 is equal to 0. From this, What I can write 5v by 6, 5v by 6, 10v by 6 is 5 by 3v, 5v by 3 minus or equal to 12 plus 50 by 3. 36 plus 80 is 50 is 86 by 3. 5 is 86. 3 is 86 by 5. 86 by 5. 20 minus 10 minus 1 by 2 into 86 by 5. 8.6. 10 minus 8.6 is 1.4 amps. Is it clear? Is it clear? 1.4 amps. Okay, I hope everyone are trying this and you did the same way, or did you try in any other different way? Did you find any problem doing these kind of problems, mesh analysis and nodal analysis? Want any more further explanation for this super node, super mesh? So if we are through this, I'll start the new topic. Network theorems. Okay, sir. What about the other people? Okay. I'm starting the new topic, network theorems. What is superposition theorem or superposition principle? What is superposition theorem or superposition principle? So when do we use superposition theorem? When do we use superposition theorem? Superposition theorem or superposition principle is used when there are more than one source available, one independent source available, more than one independent source available, then we use something called a superposition theorem. Okay, so what is superposition theorem states? It states that superposition principle states that the voltage across or current through an element in a linear circuit is the algebraic sum of voltages across or current through that element due to each independent source acting alone. So if I have more than more than one voltage or current source, I want to find a voltage across or a current through a particular resistor or a particular element, what I can do, I can consider each source separately, each voltage source or each current source separately, and find them responses, find the current or voltage across the particular element, and you can algebraically add them so that you will get the same value, you will get the final value. Okay, you understood this? So this is what is superposition principle. Superposition principle states that the voltage across or current through an element in a linear circuit is the algebraic sum of the voltages across or currents through that element due to each independent source acting alone. Due to each independent source acting alone. So each independent source should be acting alone. For that, what you have to do, you have to kill the other sources, kill all the other independent sources, not the dependent sources, only the independent sources. You can kill them, you can turn them off, you can call it switching off or turning off or killing them. Okay, so the steps to apply superposition principle, it's better if you can able to write down all this. Okay, obviously you'll be having the recording or you can take the screenshot, but it would be better if you can write it on with a pen and paper on your notebook. That would be better. Okay, so something that is written with hand is better than you can like reading. Okay, so steps to apply superposition principle. We consider one independent source at a time. We consider only one independent source at a time, while all other independent sources are turned off. Turning off of independent source. You have to understand this. Turning off of independent source, or what you call killing an independent source. That means this implies that we replace every voltage source by 0 volt or a short circuit, and every current source by 0 amperes. That means open circuit. So 0 volt is a short circuit, 0 amps is a open circuit. So voltage source should be shorted and current source should be open. You have to turn off this. Turning off in the sense you have to make them 0. By making voltage source 0, you're making a short circuit. By making a current source 0, you're making an open circuit. So current doesn't flow or current is 0 when there is an open circuit. So what happens? Yeah, we have to replace voltage source by a short circuit, current source by an open circuit, and find the voltage due to that active source using various techniques like nodal analysis, mesh analysis, or source reduction methods. You have seen source reduction, right? You can convert a voltage source to current source and current source to voltage source, and you can reduce the network. Okay, you can use one of them, and you have to find the current through or voltage across, find the output. Okay, find the output using that source. And what you have to do, the dependent sources are left intact because they are controlled by the circuit variables. Okay, or the network variables are controlled by the circuit variables. You should not kill the dependent sources. Only independent sources should be killed. So repeat step 1 for each of the other independent sources. So step 1, you have to repeat for all other independent sources. Find the total contribution by adding algebraically all the contribution to the due to the independent sources. So after finding the output by single source, by each source, you have to add all of those outputs and you'll get the total contribution of these independent sources. This is about the superposition principle. Okay, superposition principle, you have to remember, this is used to find voltage across or a current through any network element. Any network element, if you are having more than one independent source. More than one independent source. You can have two voltage sources, two current sources, more than two voltage sources, more than two current sources, or a combination of voltage and current sources. You can use this superposition theorem. And this applies only for a linear circuit. You will see what do you mean by linear circuit. Linear circuit in the sense the voltage and current ratios, voltage and current are linear to each other. Okay, so only for the resistor circuit, and it is used to find the voltage and currents. Okay, and you have to remember this superposition principle. You cannot apply for powers. Power is not a linear element. Okay, you cannot apply for powers. This is important. Don't apply superposition theorem whenever I say you find the power. Power is not a linear, what you call linear. Okay, power is not linear, so it's better. Why power is not linear? So what the voltage and current equation of power? Power is nothing but your V square by R. Power is or I square R. Power is nothing but V square by R or I square R. So this is not directly proportional to voltage or current. It is proportional to square of voltage or current. Okay, power is proportional to square of voltage or voltage and current. So you can't directly write power is not a linear element, linear quantity actually, linear quantity. So if you see in AC circuits and all, it will be like better understand. You can understand it better. It's not linear, what you call quantity. Power is not a linear quantity. Okay. So for example, let me solve this. Find the voltage V0 using superposition theorem. So what is voltage V0? V0 is this voltage across the 2 ohm resistor. So this is a linear circuit. It consists of resistances. So I'll apply superposition theorem and find the voltage. For this, what I have to do? I have to consider I have more than one independent sources. I have a current source as well as a voltage source. So what I have to do? I have to consider each source separately and I have to find the voltage across this and algebraically add them so that I'll get the total V0. Okay. So what I'll do, I'll consider once with voltage source acting alone, I'll turn off all the other independent sources and then I consider the other independent source and turn off the rest. Okay. So if I consider the voltage source first, if I consider the voltage source, 10 volt voltage source first, 10 volt source. So what should I do to the current source now? I have to turn the current source off. What do you mean by turning a current source off? What should I do? Turning a current source off. So what do you mean by turning a current source off? Given in the last slide. Yeah, open circuit. Okay, current source off is nothing but your open circuiting. So this is my current source. I'm opening it. This is 2 ohms, 3 ohms, 5 ohms. I want to find the voltage across this V0. So how do you find this? So if you can see, these three are in series, 5 ohms, 3 ohms and 2 ohms. So I want to find the voltage across the 2 ohms. So I can use directly something called as voltage division rule. So if you remember what voltage division rule, can someone tell me what is V0 in terms of 10 volts and the resistances? Voltage division rule. Can someone tell me V0? V0 is nothing but always remember voltage division rule. If I want the voltage across the series element, I have to write down the total voltage into the same resistance divided by the total resistance. What is the total resistance? 5 plus 3 plus 2, 10. So this is 2 volts. So V0 dash, I'll call it as V0 dash because of 10 volt source. It is 2 volts. Okay, V0 dash is 2 volts. Clear? Everyone? Shall I repeat? I hope V0 dash is clear. So I'm considering the 4 amp source. 4 amp source acting alone. Okay. So 4 amp source acting alone. What I have to do, the 10 volt source? 10 volt source should be turned off. What do you mean by turning off a voltage source? You have to short it. Shorting the 10 volt source. What will I get? This is how the circuit becomes. This is 4 amps, 5 ohms, 3 ohms, 2 ohms. And this is what I'll call as V0 double dash. Okay, V0 double dash. So V0 double dash. So how to find V0 double dash? I can find the current here. Let me change the color. I can find the current here, and I can multiply the current with this resistance. I'll get the voltage. Okay. I want the current in the 2 ohm resistor. How to find the current in the 2 ohm resistor? Current division rule again. Total current into the opposite resistance 5 by the total resistance. So if you can observe this, 5 ohm resistor is in parallel with the series combination of 3 and 2. So 5 ohms and 5 ohms are in parallel. So the current gets equally divided. You can write as the total current is 10. So this is 2 amperes. Okay, I2 ohms is 2 amperes. So V0 double dash will be 2 into 2, 4 volts. So V0 will be adding V0 dash plus V0 double dash. So you have to clear with the direction. So this is plus, the current is flowing this way. So this will be positive 4 and this will be positive 2. So V0 is 4 plus 2 is 6 volts. V0 is 6 volts. If you want, you can verify it with your other methods, match and nodal analysis. But this is how you do it in a superposition theorem. Everyone clear? Everyone clear with this? Shall I repeat or clear? Yeah, clear. Okay. So I want you to do this next problem. Find the current through 1 ohm resistor using superposition theorem. Find the current through the 1 ohm resistor. This is the 1 ohm resistor. Find the current through the 1 ohm resistor. I'll give you some time. I want everyone to try this. Using superposition theorem, in the sense you have 3 sources, 3 independent. Find the current through the 1 ohm resistor. Let me give you the direction also. This is the direction of the current. It can be positive or negative. You can find it. So find the current through this using the 3 sources available. Okay, 3 sources available and algebraically add them. I'm giving you time. Just find the current through the 1 ohm resistor. So any answers? Any answers? Okay, let me do it. I think someone replied. 4.6 amperes. Okay, let us see. So I'll consider each source acting separately. I'll consider the 4-volt source acting separately. Okay, 4-volt source. I'll call it as I. Okay, current I. So what happens now? So I have to turn off 3 amps and 1 amps. I have to open them. So this is how my circuit will be. This is 4 volts, 2 ohms and 1 ohm. So when this is open, no current flows through this. Current is 0. So these two are in series now, 2 ohms and 1 ohms. I want the current here. I is equal to 4 by 3. So I'll call it as I dash. Okay, through by 4 volt source, the current here is 4 by 3 amperes. So current here is 4 by 3 amperes due to the 4 volt source I dash. Okay, now considering the 3 amp source acting alone. 3 amps source acting alone. So what I have to do, I have short this and open that. So this is how I'll get my circuit as. This is the 3 amps, 3, 2 and 1. I have to find the current here. So again, if 3 amps is coming here, it is getting divided. So I can get directly as I double dash is equal to 3 into opposite resistance by total resistance. This is 2 amps. Clear? If I consider 1 amp source, 1 amp source, I have to open this and short it. So this is my 1 amp. Sorry. This is my 1 amp source. So if you can observe this is opened, okay, 3 ohms, 2 ohms, and 1 ohm. So how are these two, 2 ohms and 1 ohms? 2 ohms and 1 ohms. Can you someone tell me 2 ohms and 1 ohm resistor? 2 ohms and 1 ohm resistors are in. 2 ohms and 1 ohm resistor are in. They are in parallel. They are in parallel, right? Yes. Yes, Ditanshu. Yes. So these two are in parallel. 1 amp is coming here. It is getting divided. So I triple dash will be 1 into opposite resistance by total resistance. This is 2 by 3. So the total resistance I is equal to I dash plus I double dash plus I triple dash. So 4 by 3 plus 2 by 3. 4 by 3 plus 2 by 3 is 6 by 3 is 2. This is total 4 amperes. 4 amperes. But you got 4.6. 4 amperes is the answer. Is this clear? Or shall I explain it again? Any doubts anywhere? I think I have given you enough time to solve it by yourself. Then I attempted to solve it. And also you have to consider the direction of current. All the cases, the direction of current is downwards only. Okay. Okay. Is it clear or shall I explain it again? Can I move to the next?
Hello.
What?
Hello.
Yes.
Yes, sir. If there are more than one sources, independent sources,
Yeah.
that time we need to consider just one source at a time, and other all source will be removed, right?
Yes. Yes.
Okay.
So you have three sources here: 4-volt source, 1 amp source, and 3 amp source. I consider the 4-volt source first. I remove these two sources, and then I consider this 3 amp sources. 3 amp source, and I remove these two. Then I consider the 1 amp source. Then I consider the 1 amp source and remove these two. Okay. So this is
Yes,
how
sir.
you do. Yeah, this is how you do using superposition theorem. Okay. Next topic is homogeneity principle. What do you mean by homogeneity principle is homogeneity is the property homogeneity is the property that requires if the input is multiplied by a constant, then the output is also multiplied by the same constant. Input in the sense excitation is multiplied by the constant, then the output is nothing but your response is multiplied by the same constant for a linear network. Again, this is for a linear network. If I am this applies for resistance. So this is resistance and this is my voltage across it and current through this. So if the voltage applied is V, the current is I. V is equal to IR is Ohm's law. So if I multiply the voltage by K times, KV is equal to again K times IR. So if I multiply voltage by K, excitation or the input by K, the output is also multiplied by K. That is nothing but your homogeneity principle. So a linear circuit will always obey homogeneity principle. Remember this, a linear circuit will always obey homogeneity principle. Okay, what does homogeneity principle says? If the excitation or the input is multiplied by a constant K, then your output is also multiplied directly by that constant K. For example, if you see this question, using homogeneity principle, find the value of find the value of all the branch currents if your source voltage is changed to 60 volts. Now, previously I have a 20 volt source. And I have to find the branch currents in each of these branches, 3 branches. Then if the voltage is changed to 60 volts, you have to find the voltages across these 3. Okay. So first of all, with 60 volts, let me do this. So tell me the currents everywhere. So how are these two, 4 ohms and 4 ohms? How are these two? These two are in. This 4 ohm resistor and this 4 ohm resistor are in. parallel, right? These two are in parallel. So what is the equivalent resistance? 2 ohms. So what will be my circuit? There is a 3 ohm resistor and a 2 ohm resistor connected to a 20 volt source. I will be 20 by 5. 20 by 5, 4 amperes. Right? Clear so far? So this is my 4 amps current. And the same current is coming 4 amps. So the current is coming here 4 ohms and 4 ohms. The current gets equally divided because the resistances are equal. It gets equally divided as 2 amps and 2 amps. So you got the branch currents. The branch current here is 4 amperes. Branch current here is 2 amperes. Branch current here is 2 amperes. Now what happened? I changed the source voltage from 20 volts to 60 volts. 20 volts to 60 volts. So the K is 3 times. So I'm multiplying my source by 3 times. K is equal to 3. Okay. So what happens to the branch currents? I 3 ohm resist will now become at voltage or 60 volts or K equal to 3. 3 times the previous current 4 amperes is 12 amperes. And 4 ohms it becomes 3 times the 2 amps 6 amps, and I the other 4 amps will also equal to 6 amperes. Okay, so as the voltage input source is multiplied by K times, the outputs or the responses will also get multiplied by K times. Okay, so what are the values here now? The new values with 60 volts, this will become 12, 6 and 6. Otherwise you can do it. You can do it here. So if instead of 20 you have 60, so I will become 60 by 5. This is 12 amperes. So 12 amps when comes here divides equally as 6 and 6. Okay, 12 amps coming here will equally divide as 6 amps and 6 amps. So when your input is multiplied by K, all your outputs get multiplied by the same constant K. Okay, again this is applicable for linear elements and linear quantities. Okay, this is about homogeneity principle. Okay, nowadays with the combination of homogeneity and superposition, you are getting some very good problems. Okay, let's solve one or two problems from the previous gate questions. Okay, is it clear everyone? Shall I move on? If you're clear with homogeneity and superposition, the next problems are easier. Okay, so you have to understand this homogeneity principle and superposition. What actually you have to understand is when multiple sources are present and more than one source are present, first apply superposition theorem and later apply homogeneity principle. That is, whenever homogeneity principle is applied, make sure that only one source is present in the network. Okay, this is important. So when you are applying homogeneity principle, make sure that only one source is present in the network. Okay, if there are more than one sources, use both combination of homogeneity as well as the superposition theorem. Yeah, okay, yes. Next. So I want you to solve this. This is a previous year gate question. I think the whole question is visible. When Vs equal to 120 volts, it is found that I1 is 3 amps, V2 is 50 volts, and power delivered to R3 is 60 watts. 60 watts here. If Vs is reduced to 105, find the new values of I1, V2, and power dissipated to R3. Okay, you have a linear resistors here. You have source voltage Vs. You have resistor here R2 and R1. This is the current through the resistor R1 as I1. Voltage across the resistor R2 as V2. The power delivered in the resistor R3 as P3. So let me solve this first question and I want you to solve the other questions. Okay. So let me solve the first question for you. Okay, everyone onto the screens. Everyone to their screens, please. Okay, so what is given? If Vs is equal to 120 volts, then it is found that I1 is 3 amperes and V2 as 50 volts and power delivered to the resistor R3 as 60 watts. Power delivered to V3 as 60 watts. Now what is given? Now if the voltage is reduced to 105 volts, find I1, find V2, find P3. So again, homogeneity principle. If your source is multiplied by k times, your output is also multiplied by k times. If your excitation is multiplied by k times, your response is also multiplied by k times. Now, if it is 120 and 105, yeah, some message. Okay. If it is 105 from 120, what will I1 be? I1 is equal to 3 into 105 by 120. 3 into 105 by 120. Okay, again same. V2 is equal to 50 into 105 by 120. So what about P3? So as I already told you, power is not a linear quantity. You can't directly do in terms of power. Or what I can do, power is nothing but I can convert it in terms of voltages or resistances. So voltage across V3 can be written as V3 square by R is equal to 60 R3, or V3 can be written as under root 60 R3, right? V3 can be written as under root 60 R3. So again here also V3 can be written as under root 60 R3 into 105 by 120. So power P3 is V3 square by R. V3 square is under root 60 R3 square by R3 into 105 by 120. So under root and square gets cancelled. So this will be R3 by R3 gets cancelled. 60 into 105 by 120. Tell me the answer. This will be 60 into 105 by, sorry, so this is also square, right? V square by R. 105 by 120 square. Okay. You can write in terms of current also. 105 by 120 square into 60. 105 by 120 square into 60 is the answer. So tell me the answers for I1, V2 and V3. I1 will be 3 into 105 by 120. What is the answer? Hope everyone is having calculators. 2.625. 2.625, yeah. And then V2. Then V2. V2 is 43.75. Okay. Then P3. I have 43.75 V2 and 2.625 and P3. I want the answer for P3. Why do we square the factor for power? So that's what I'm telling you. Okay. 52.5. 45.93. Why are you getting two different? I'll explain you just a minute. 45.93. These are the three answers. Okay. Why we have to multiply or this do this square for power. Power, as I told you, is not linear. So power, so P2 by P1. If I write P2 by P1, it will be V2 square by V1 square into R by R. Okay, this R gets cancelled. So V2 square by V1. V2 will be K times the what you call voltage. So P1 already is given as 60, right? 60 into V2 square by V1 square. 60 into 105 by 120 square. Power actually is not linear. It depends on voltage square or current square. Power is nothing but V square by R or I square R. You can use any of them. You can use current square or voltage square. Explain P3. That's what I'm doing. Okay, this is P3. Okay, this is P3 dash by P3 double dash or P3 double dash by P3 dash. Okay, so power here is power here. If I can write down with proper nomenclature, will be something like this: P3 double dash by P3 dash. P is equal to V3 double dash square by R divided by V3 dash square by R. So R3 gets cancelled. So this will be V3 double dash square by V3 dash square. So P3 double dash is equal to P3 dash into V3 double dash by V3 dash whole square. Is this clear? Now P3 dash is equal to 60 into V3 double dash is 105 by 120 whole square. Understood, sir. Okay. Okay, even if you consider currents also, you'll get the same. Okay, currents also you'll get the same. This is how you'll do it. Okay. Okay, shall I move to the next question? Is it clear to everyone? This is very important because these kind of problems you are getting. In 2019, you got the same problem. Okay, similar problem actually. We'll do that one also. Okay, so if you are clear with this, I'm going to the next question. Clear, right? This is clear, everyone? So try to solve this. If you are clear with that, now solve this. A linear network contains only resistors. Okay, this is a linear network consisting of only resistors. You have two current sources. Okay, two current sources. If IS1 is equal to 8 amperes and IS2 is equal to 12 amperes, Vx is found to be 80 volts. Now, if IS1 is minus 8, IS2 is 1 ampere, Vx is 0. Find Vx when IS1 equal to IS2 is equal to 20 amperes. Try to solve this. I'm giving you time. The one who can solve this, you'll definitely get a very good rank in GATE, at least below 500. Any answers? Okay, I'm doing this. See, again, I have multiple sources. So first of all, I have to do something called the superposition theorem, and then I have to apply homogeneity principle. So similarly, see, if IS1 is equal to 8 amperes, IS2 is equal to, what is this? IS2 is equal to 12 amperes, Vx is equal to 80 volts. Similarly, IS1 is equal to minus 8 amperes, IS2 is equal to 1 ampere, Vx is equal to 0. And find IS1 is equal to IS2 is equal to 20 amperes. 20 amperes. Find Vx. This is the question. So Vx, this is a linear network of resistors, linear network given. So linear network in the sense the input and outputs are proportional. Input and output are proportional. So if Vx is, so if the sources are multiplied by a constant or multiplied by a constant, the output is also output will also follow the same. Okay, and you have more than one source, two independent sources. So the output is the sum of the two outputs with the two sources, right? So I can write Vx in terms of IS1 and IS2. See here, look here. A into IS1 plus B into IS2. So this is one equation I formed for this. That means the voltage Vx depends upon the everyone to the screens. The Vx voltage is equal to some constant into IS1 and some constant into IS2. Okay, some constant into IS1 and some constant into IS2. So from the first equation, it is Vx is equal to 80 is equal to 8 IS1 plus 12 IS2. Sorry, IS1 is given, right? 8a plus 12b. 8a plus 12b. This is my equation 1. So here 0 is equal to minus 8a plus b, or minus 8a plus b, or a is equal to, or b is equal to 8a. You can substitute this and find the values of a and b. Tell me the values of a and b. So b is equal to 8e by 13. And a is equal to 8 into 80 by 13. Eighty by 13 is 6.15 and b into 8. 640 by 13, let it be 640 by 13. Now Vx, find Vx when IS1 and IS2 both are equal to 20. So what I can do, 20 into 640 by 13 plus 20 into 80 by 13. So this will be my Vx. So find the value of Vx. Answers. Any answers? So I want you to find this. You'll get something, some value of Vx. Okay. It's a direct question. 11 okay. Just check it. Check it once. Okay. You have to understand the concept actually. Okay. Understand the concept. This is a simple question if you understand the concept. This is a simple question if you understand the concept. The concept is here is you have to apply both what you call homogeneity principle as well as superposition theorem. Superposition theorem states if you can algebraically add both the responses, and homogeneity principle says that if your excitation of the source is multiplied by a constant, your response will also be multiplied by the same constant. Okay, I hope everyone understood the concept, right? Yeah, let's try this question. Try to do this. This is a gate question. I want the answer from everyone. I want the answer from everyone. The previous question is clear, right, everyone? Previous problem is clear. Or you want me to explain it again? If that is clear, I want you to solve this. See, I'll give you assignments, but I just want to complete some portion at least theorems. By after theorems, at least let me complete 8 to 10 hours of class. Then I'll give you some good assignments. You can actually, the same problem can be done with different type of methods, right? Different techniques. So I want you to use the best technique. For that, you have to complete some of the portion. I want you to complete the Thevenins and Nortons. I want to complete Thevenins and Nortons today, but I don't think that's possible. Let me complete this question. Okay, are you doing, or shall I wait, or shall I do it? 80 by 104. Okay, we will see that actually. Is the procedure you Mr. Manoj, you followed the same procedure, or did you do it any other way? You can share me the what you call the solution you did, and we will see it. Okay, we can same procedure. Okay, same procedure. Then I think the numericals you have to check it once. Okay, numericals, just check them. Okay, if you still have any doubts, I can we can do it in WhatsApp also. Okay. So try solving this question. So a particular resistor R, this is my resistor R. This dissipates a power of 4 volts when voltage source V alone is active. Okay, the same resistor R dissipates a power of 9 watts when I alone is active. The maximum and minimum power dissipated by R when both the sources are active simultaneously will be. So why will you get two conditions, maximum and minimum, when both are acting? Why will you get two conditions, maximum and minimum? Anyone? So this is a case of, again, superposition theorem. Clearly, I have two sources. Each source considering, I am getting some power here. So if both are acting, I'm getting two powers, because I don't know the resistive network, nature of this resistive network. I don't know the direction of current with this source and this source, right? If both the sources are aiding, I'll get one output, and if both the sources are opposing to each other, I'll get the other output. You understood why there are two maximum and minimum powers? Maximum when both are aiding, minimum when both are opposing. Okay, everyone look at the screens. Maximum and minimum powers. Okay, maximum and minimum powers, because when both are acting, they can be aiding or they can be opposing. Okay, when individually there is 4 watts by voltage source, 9 watts by current source. Okay. So again, I told you, I can't directly consider the powers when I use superposition theorem. So I have to convert the currents into voltages or currents. Okay, I did it with voltage. I can do it with current or voltage now. If you want, I can do it with voltages or currents, or I'm doing with currents. If you want, I'll do it with voltages also. Okay, considering voltage source. So considering voltage source, the power dissipated in the resistor is 4 watts. Okay, power dissipated is 4 watts. So this is V square by R is 4 watts. So V is equal to okay, this is when voltage source is there, 2 root R. When current source is present, it is 9 watts. Again, I can convert the same into power. V square by R is equal to 9. V is equal to 3 root R. Okay, when both are acting and aiding, I'll consider aiding in the sense maximum. Maximum, what happens? Voltage is equal to 2 root R plus 3 root R. Okay, 2 root R plus 3 root R. This is 5 root R. So power will be V square by R. 5 root R square by R. 5 root R square by R. This is 25 watts. 25 watts. And minimum is opposing. When both are opposing, I'm writing it here. Opposing, what happens to my V? 2 root R minus 3 root R. This is root R or minus root R. The power will be minus root R square by V square by R. This is 1 watt. Okay, so the maximum is 25 watt, minimum is 1 watt. Option D. Everyone understood? You have to convert these powers into voltages or currents. You have to convert this 4 watt and 9 watt into voltages or current. I convert them into voltages here. You can convert them into currents also, and you can find the powers. When both are aiding, the voltages will aid. If you consider currents, the currents will aid. Okay, both the voltages are added here. If both the voltages are added, 5 root R. So power is again V square by R. You'll get 25. And here also the voltages are opposing. You got minus root R or root R. Root R square by R is 1. So it is 1 watt. So when they are aiding, you get 25 watts. When they are opposing, you get 1 watt. Is it clear? Is it clear to everyone? Repeat. Okay. See, when you have two sources, your power dissipation using one source is 4 watt here. Using voltage source is 4 watt. Using current source, you have 9 watt in the resistor. Okay, so you can't directly add. So maximum and minimum powers when both are acting at the same time. And when both are acting at the same, by superposition theorem, you can add voltages and currents. Not add voltages and currents algebraically based on their directions, okay, but not the powers. So you have to convert these powers into voltages. Power is equal to V square by R or I square R. So I've used V square by R here. You can use I square R also. So I have used V square by R. What I got? V square by R is equal to 4. So V is voltage across this resistor. Okay, voltage across this resistor. Okay, I can call it as V dash for your clarity. This is V dash. Okay, V dash. Okay, V dash is nothing but voltage across the resistor. So this voltage across the resistor is 2 root R. If voltage source V is acting alone and current source I acting alone, the voltage across this resistor is 3 root R. Because the power is 9 watts, so V square by R is 9, V dash is 3 root R. Okay, when these two are acting at the same time, they can be aiding or they can be opposing. If they are aiding, what happens? these voltages get added. If they are opposing, these voltages get subtracted. So when they got added, I got 5 root R. The power is again voltage square by R. 5 root R square by R is 25 watt. And when they are getting subtracted, is 2 root R minus 3 root R is minus root R. Power is equal to minus root R square by R is 1 watt. So the maximum is 25 watt, minimum is 1 watt. Is it clear now? Any more clarifications needed? You can unmute, mute and talk instead of typing also. Clear? Yeah. Okay, shall I stop or shall we do Thevenin's theorem and all? You can use current source and do the same problem if you want. Okay. Yeah. I think it's 4:48. If you want, I can go on. Or let's meet tomorrow and we'll do the remaining theorems tomorrow. Okay. You have Thevenin's theorem, Norton's theorem, maximum power transfer theorem, and there is something called as reciprocity theorem. We'll do see them. Okay. Parallel generator theorem. We'll do them tomorrow. Okay. Yeah. Thank you. Are there any doubts from today's class? Can we conclude it? Any doubts from today's class? Am I audible? Any doubts from today's class? I want you to practice more and more previous year question papers. Please let me complete the network theorems and we can do some other problems. Okay. In concluding the class, I don't get any I'm not getting any responses from you people. So I hope everything is clear. Okay. Concluding the class. Thank you. Okay. Okay, this is a GATE 2017 question. So try to answer this. So from the question, when you read the question, you will be able to draw the circuit, how the circuit is. It said that a connection is made by resistance A in series with a parallel combination of B and C. So there is a resistor A in series with a parallel combination of B and C. Okay, A, B, and C. There are 3 resistors, and A is in series with parallel combination of B and C. 3 resistors of value. You have 3 resistors: 10 ohms, 5 ohms, and 2 ohms are provided. Consider all the permutations. So you have to keep these 3 resistances: 10, 5, and 2. 10, 5, and 2. 10, 5, and 2 in the places of A, B, and C. You can keep 10 anywhere, 5 anywhere, and 2 anywhere, but you have to use all the 3 resistances, and you have to find the maximum overall resistance and minimum overall resistance, and the ratio of maximum to minimum. The ratio of maximum to minimum value of resistances, you have to find that. That is the question given in GATE 2017. So this is a 2 marks question and it is a very important question. So you have to understand some concepts here. See, when 2 resistors are in parallel, or what you call in parallel, when 2 resistors are in parallel, the equivalent resistance, the overall equivalent resistance will be less than the minimum of both. both the resistances. For example, I'm having a 10 ohm resistor and I'm having a 100 ohm resistor. So the R equivalent will be less than 10 ohms. Okay, if this is 1000, still 10,000, any amount of zeros, the overall resistance will still be less than this value only. Okay, you have to remember this. If there are two resistors and connected in parallel, the equivalent resistance will be less than the minimum of the minimum of both the resistances. This is valid in case of parallel networks. Okay, so I hope you're taking down in your notes. Okay, this is one of the important concepts. Okay. So coming to the question again. So now you have three resistances. The combination is given. The combination is like this: A, B, and C. Now you have to find the equivalent resistance, keeping 10, 5, and 2. So tell me if I want for maximum resistance between these two terminals, maximum resistance. So if I have the minimum resistance of 2 ohms here, or 2 ohms here, and so sorry, if I use 2 ohms here, I have 10 and 5. 10 and 5, which should be A and which should be B? If this is 10 ohms and this is 5 ohms, the parallel combination will be less than 2 ohms here. Okay, less than 2 ohms, and this will be in series. So if I use 10 ohms, this will be minimum. The value you'll get is less. So what should be the combination for maximum? This is 2, this should be 5, and this should be 10. Maximum resistance 10 plus 5 parallel with 2. Everyone clear with this? How I got the maximum resistance? Shall I repeat it? You can unmute and ask me if you have any doubt. Okay. So for minimum resistances, from minimum value of resistance. So meanwhile, file the value 10 by 7. 10 plus 10 by 7, 70, 80 by 7. Okay, maximum resistance is 80 by 7. Okay, now I want to find the minimum resistance. Minimum resistance. From minimum resistance, I want 2 here. I can have 10 and 5 combination here, or I can have 5 here and a combination of 10 and 2 here. Okay, either way, this combination or this combination, we have to check which one is the lowest. If this is combination, this will be less than 2. If this combination is used, less than 5. So I have to find both ways. So what I'll do, I'll find this one using 10, 5 parallel with 2 parallel with, okay, or I'll take minimum of 2 parallel with 10, sorry, 2 series with 10 parallel, 2 plus 10 parallel with 5, or 5 plus 10 parallel with 2. Okay, so minimum of these two. So 10 parallel with 5 is 10 by 3. 10 by 3 plus 2,